So basically, statistical significance versus practical significance. If something is statistically significant, does that mean that it's really important to you? Well, let's think about it. It tells you whether or not the difference is likely to be due to chance. Well, yeah. Not whether the difference is really important, not whether it's a huge difference or not that might be important to you, just whether you're likely to see such a difference due to the luck of the draw. Okay? So if you have a big enough sample size, when you have a huge sample size, very, very, very small differences that you might not care at all about can be statistically significant. For example, suppose you wanted to compare IQ scores of men and women, and you take a simple random sample of this is a huge sample of men and a huge sample of women, 10,000. My pen ran out. And I don't have another one. Yeah, maybe. Okay, 10,000. That's your N. And the men average 100, and the SD is 20, and the women average, oh, look, they did a little bit better, 101. So you wonder, oh, it's only a 1-point difference. That's probably not going to be significant. You know, just by the luck of the draw, you could get a 1-point difference. But remember how we figured that out with the z-score. I'm not going to go through all the calculations, but basically, well, I could just do the z-score to show you what I mean. Do you think this 1-point difference is going to be due to the luck of the draw or not? Well, you think 1-point difference. We don't care about, who cares about a 1-point difference? It's probably due to the luck of the draw. But then you think, wait a minute, what do we mean by that? If we had the entire population of all the men in the world and all the women in the world, even that 1-point difference, we'd say, is significant because we'd have everybody's score. So even a tiny little difference can be significant if your sample size is big enough. And is this big enough, 10,000? Well, I think it would be, because look what happens to our standard errors. Remember, our z statistic would just be that difference, which is what? 1 point, right there. 101 minus 100 minus the expected, which is 0, over some standard error for the difference. Okay, standard error for the difference. And watch what happens when n is big. When n is big, okay, what is that standard error? So you have 1 divided by, and the standard error of the difference, it's like the hypotenuse of a triangle. It's the square root of the sum of the squares, where each one of these squares is a standard error. So this is the standard error for women, and this will be the standard error. They're both standard errors for what? Averages. But this is average for the women, and this will be average for the men. All right? And the standard error for the average, we can do it just quickly inside here, is what? SD. I don't expect you, I just want to show you why this works out though. SD over the square root of n. And when n is really huge, like 10,000 for both of them, 20 over the square root of 10,000. What's going to happen is our error is going to get really small. So we'll get, when you divide by a small number, you'll get a big z-score. So when we do this, and you don't even have to write this down if you don't want to. I just wanted to show you how it would work out. And when we do this, I'll just put it up here, we get what? Our z-score is going to be 1 divided by the square root of 20 over the square root of 10,000. That's 20 over 100, right? Isn't it 20 over 100? So that's 0.2 squared plus 0.2 squared. And when we do that, the 1 over there, we're going to get something, I'll do it, and I think we get, what do we get? The square root of 0.2 squared plus 0.2 squared. I hear that on some of your exams, like, you're not allowed to use these graphing calculators, are you? What reminded me is I just made a mistake by not putting all the numbers in. I don't know if I would have been able to detect on one of those little scientific calculators. It must be very hard for you guys when you can't use these, just because you... Okay, so I have that, and then what do I want to do? What's funny? Okay, I get 3.54. 3.54. Okay, so that's a huge z-score. So all I want to show you is it's significant. That's a huge z-score. You know, it's going to be way out on the tail. It's going to be, you know, between 3. You don't have to even write this down, but I just want to show you that you can get these huge z-scores when you have very tiny, small standard errors. But do you really, really care? It comes out significant. It's going to be p is going to be, I don't know, approximately 0.02. Between 3.54 and negative 3.54 is 99.96. So we say it's significant. However, even though it's statistically significant, I don't care about it. I mean, who cares, really? So all I want you to realize is something can be, a very tiny, tiny, tiny difference can be statistically significant. That doesn't mean it's important. You have to think about that more. All right? And similarly, let's say you had a really small sample size. Then you'd have huge standard errors, and maybe a really important difference wouldn't come out statistically significant. You wouldn't see the difference if you only had a few people. Just because of the luck of the draw, you wouldn't see it. So that's what I say here, both of these things. So all I want to say is that statistical significance is different than practical significance. All right, now let's look at the next thing. With enough tests, significant results will appear by chance. Now this happens all the time, all the time. People do all these experiments and they don't report how many they've done, and then when that one comes up significant, they say, whoa, significant results, pay attention, I'll get published. This happens a lot of the time. And it's really, I mean, even people who are think they're being scrupulous. I remember when I used to be years ago, when I used to consult around campus and just help people do their statistics, and my little kids were small, and I didn't want to leave them, wanted to just be a stay-at-home mom, so it was very easy to do. And so I would just help people in different departments, and over again it would come up with people would have questionnaires, for example. Huge questionnaires. I'm sure you get these questionnaires that have 100 questions in them, or 20 questions even. And then they don't even realize what they're doing, and then one of them pops up really unusual, statistically significant. They have not identified that beforehand. Well, just by the luck of the draw, you're going to get 1 out of 20 at a 5% level. By definition, that's what it means. It means even if nothing unusual was going on. That's what 5% significant level means. That even if there's nothing interesting going on here at all, and they're looking for these interesting results in these surveys, even if it was the dull, no difference between these two conditions at all. You ask 20 questions, and you don't identify ahead of time, hey, this is the question I'm interested in. Well, then just by the luck of the draw, you're going to get probably one of them that comes out significant, because that's by definition. And then they'd say to me, well, look, we got a significant result. I said, no, you didn't. You did not get a significant result. You just got what you'd expect by chance. You have to identify ahead of time which ones. And that's why a really good reason why it's not a good idea to ask these huge surveys. It's much better to say, hey, I just have a few questions I'm going to ask, and otherwise you're going to have to repeat the survey. Once you think, oh, this is the one that's important, well, then you're going to have to do another survey. Whereas if you just asked a few questions to begin with, you wouldn't have to do that. And people just feel like, I'm just going to pile as many questions as I want, and as many questions onto the survey, and it's horrible for them. They can't get any results out of it. And it's even worse for us, because how many of you have gotten a boring survey where it just goes on and on and on? Raise your hands. And after a while, another phenomena happens. You don't even answer honestly. You just, at least I don't, you just want to get through with it, right? Do you even pay attention anymore after a while when it's like a 100-question survey? Do you? No. Have I been guilty of that in my surveys? Tell me. Have I asked you too many questions on a survey, do you think? No, I would never, ever do that. For one thing, I couldn't get any results from it, and you would be bored stiff. It's a lose-lose situation. No one seems to understand that. So, and here's, okay, so here's with enough tests or enough survey questions, it's all the same deal. Significance results are gonna appear by chance. You have to then do further testing. It's more work for everyone. So here's an example. If you run 100 tests, you expect 5 to result in statistically significant results, even when the null hypothesis is true. Remember, you're usually trying to show the opposite, the alternative, that something interesting is going on. So beware of claims of significant results when many tests are run, or many different questions have been asked. That's the same thing. Running the same test over and over and over again on one person is the same thing as running, you know, taking a test on 100 people at once, or running 100 survey questions. It's all the same stuff. It's just by chance you're going to have, okay, so here's an example that was sort of motivated by the Aaron Brockovich movie, which I actually like that movie. But liver cancer is a rare disease which may sometimes be caused by environmental pollutants, and the chance of having 2 or more cases in a town of 10,000 is small, just 0.5%. So if you find, since it's such a tiny chance, if you find a cluster of liver cancers in one town, well, that is alarming. That is, because you only expect to find it 0.5% of the time. But what if the EPA reviews the incidence of liver cancer in 100 towns? Not just looking at this one town, over this, about this size, over a 10-year period, looking for possible environmental contaminants. How many clusters would you expect them to find just by the luck of the draw, even if every single one of the towns was completely clean and didn't have any contaminants? Just because, unfortunately, people get liver cancer just, you know, for other reasons, and unfortunately, and just by the luck of the draw, there's going to be a few of them in a town. How often? Very rarely, but if you're looking at a lot of towns, that's going to come up. So the question is, what did the question ask? How many clusters would you expect to find? This is a little bit harder than what you would get on your final, quite a bit. But I just want to show you. Okay, so if 100 towns over a 10-year period, how many different cases are we looking at? We're looking at 10 years times 100 towns, so we really have 1,000 cases, or town year combinations, whatever you want to call it. So now the question is, if you expect it, just by the luck of the draw, 0.5% of 1,000, if every single one of these towns is clean, just by the luck of the draw, you're going to expect 0.5% of 1,000. Well, what is that? 5% of 1,000 is 50. This is 5. So you would expect to find 5 liver clusters, 5 towns with liver clusters, you know, 5 of these town combos, town year combos, 5 instances. of liver cancer even if all the towns each year were clean. So that's not enough. That's certainly room. Let's go to this town, investigate, and then see if we can uncover something. But when you don't uncover something, you can't say, it's got to be there, they're hiding it, it's got to be there, it's got to be there, it's got to be there. No, it doesn't have to be there. We'd expect to find this much just by the luck of the draw, and if you found more, then you should be suspicious. Probably all these are clean. That's the idea. All right? Okay, so now let's do our own ESP example before we do this as an eye clicker. Last time, you know, I had you, I was looking into your eyes. I don't know if you remember, I did a card trick in this class, right? I hope I did it. And you knew I didn't have ESP. I pretended to. But now, I am just going to cut the deck here. I don't know what this card is right here, and you don't either. But what I'm going to do is look at the card, and then I'm going to put it back. Oh. And I want you to see if any of you here have some kind of extrasensory communication with me. Okay, card. This is some card. Okay? It is some card in this deck of 52. And think about it. The chance of you guessing is just 1 out of 52. So if any of you has it, it's going to be pretty significant certainly at the 5% level. So think about the cards. It's not in this half. This is the card right there. I want to I don't know, just like bring it closer to you. Feel the vibes. Feel the vibes of the card. Oh, you can't see the card, I hope. Okay, I'm going to give you just a minute, and you have to write down the card. Okay, just don't write, you have to write down the suit and the card. Okay. All right, so everybody does that. And then here's the card. And write it down so I know you're not lying. Okay, now I'm going to flip it over and see if anybody got it. Did anybody get it? One person. Raise your hand high. Anybody else? Am I missing somebody? Oh, yeah. Okay, so wait a minute. So what's your name? Who got it? What's your name? Andrea, and who else? Andrea, Peter, and who else? Say your name. Carrie, got it. Yoo-hoo. And yeah? Next to Carrie, too? No?
Oh, we have one more.
Oh, my gosh. What? What's your name? Kelly, Carrie, Peter, and Andrea. Is that right? Kelly, Carrie, Peter, Andrea. KKPA. Okay. Kelly, now, does that blow your mind? They have ESP, don't they? Certainly at the 5%. What would be the chance? 1 out of 52. 1 out of 52. That's like a 2.5% chance. That's at the P equals much less than 0.5. It's half a point. And much less than, yeah, it's about 2.5. So can we all say they have ESP? Are you convinced? Why? Why aren't you convinced? Just what?
It's just luck.
It's just luck. Why are you so sure it's just luck, though? You don't even seem surprised.
I'm so surprised.
What should I do to see if they really have ESP? Do it again. Right. Look how many of you there are here. I'd be very surprised if no one got it. I'd feel like I had anti-ESP. Really, if no one got it, I'd be surprised. Just think about it. There's about, what, 300 people here, right? 1 out of 50 should guess it. And how many 50s go into 350? 7 of you should have gotten it just by the luck of the draw. If there's 350, if there's 250, 5. How many people got it? 4? Yeah, we didn't even do as good as chance. Okay, but now, just those 4 people. Just those 4 people. We're doing it again. It could still be the queen. We're doing it again. Now, let's see if they get it. All right, so we'll just do it one more time. If they get it, what should we do? Just think, are we going to be convinced? All right, here we go again. All right, I'm just going to look at the card. All right, I'm not going to give you the advantage of having the physical presence of the card. I'm just going to walk around without it, see if you can still get it. I'm thinking it, just in my head, thinking. Concentrating, very difficult, it's very hard. Okay, does everybody have it written down? Andrea, you ready? Peter, ready? Carrie and Kelly, how you doing? You feeling it? Remember, there's a suit involved. And, okay, write it down. Let's see what goes. See how you do. Okay, here we go. Did you get it? Oh, are you surprised? No. Okay, this is why you have to write down, tell people, look what I did. I did multiple tests. I wasn't just testing those 4 people initially. I was testing 350 of you. And of course, so none of you were all surprised. Then when I singled them out, same way if I had a 300 question survey, of course some of them are going to come out really unusual, or even a 100 question. But when you just have 4 questions on your survey and something really unusual happens, then it's a different matter. Okay, now, let's do this one as an eye clicker. An experiment on ESP is repeated, watch, 1,000 times, not 100, but 1,000. Suppose there is no ESP. No ESP. And the experiment is done correctly. About how many of the experiments would you expect to find statistically significant evidence? Okay, statistically significant usually means what? In this case, we'll say, well, usually means what? The p-value is what? 5%. So that's what we're talking about, 5%. So what would you expect? You'd expect, and you're going to fill in the blank here, of the 1,000 to give statistically significant results by chance, even when there's no ESP. I want you to just fill this in, and then I'm going to put up there as an eye clicker, and you can see how it agrees, what number. Just put in your intuitive feeling, right? Not your intuitive. You can work this out very easily. What would you expect? 5%. Okay? Now, all right. Now you're ready for your eye clicker. Now that you see this, okay, it's going to be the same problem on the eye clicker. And here it is. Right here. Okay? So which one? Which one do you expect? So just click one. Okay, you all set? Anybody still voting? Oh, there's only 224. Okay, stop. And let's see what you said. All right, look at this. This is the correct answer, but this 5%, you have to be careful. 5% of 1,000. 5% of the time. If this was 100, you'd be right. But 5% of 1,000 is 50. Don't get that wrong on the final. You'll see something like that. Okay? All right. Now, so the answer is, I'll write that down. Here, let's just go to the document camera for a minute. And I'm just going to write it down how you figure this out. What we're talking about is 5% of what? 1,000, which is 50. How many people have done the homework so far? It's posted. All that I have left to do is post a bonus survey, and I'm going to make it short. After I told you all this stuff about short surveys, it's going to be very short. And it won't take you long at all, and that will be up tonight. Now, let me think what else we have to do. Okay, well, I only have about 7 minutes left, and that's perfect because all I want to tell you to do now is basically just remind you of what's out there to study. And there's just one, okay, first off, this chart is useful. This is your next page, 261. If you're confused about when to use a z-test, t-test, 2 sample z, and the 2 chi-squares, what the null box would look like, the formula, the p-value, you might want it all in a handy chart, and that's what this is. Okay? With examples. With each one has an example. All right. Now, that's something to look at. And here's something else, the study guide for the final. Okay. With each of our exams, I pretty much advocated jump right to the exams. Don't do that this time because you'll overwhelm yourself. I want you to go through the study guide, and what I do, first of all, I tell you the format. And I wrote this early, and I've changed it slightly. So, exam 1 material, just to let you know, it's going to be in this range, but it's going to be between 20 to 22 questions. 20 to 22, 20 to 22. That's exam 1, exam 2, and exam 3. And then here, I'm going to do what? Have between 34 to what? 40. I should have put 40 there. It has to add up to 100. 40 to 34. It's just going to range in there somewhere. More on post-exam 3 material because you have not been tested on it yet. So I want you to go through this study guide. And especially, take it exam by exam. First exam, get that out of the way. It's all in order. Then go to the second, and then go to the last one in post-exam, okay? Shh, hey, wait a minute, I don't want to compete with you. I said we still have a few more minutes, and please don't disturb other people, okay? It's a few minutes to hold it in if it's the bathroom. Come on, you're big boys and girls. If it's something else, don't even go. All right. Now, so you go, and here's exam 3, It's very long, but it's a great way to study. And then and the beauty of it is, I've translated all of it into Scantron questions, just like you're going to see. You haven't had much experience with this on the final. So all of these are Scantron. Multiple choice questions, all right? That's what I mean by it. Multiple choice. All right, you go through these all, including the post-exam, go through the key, everything's worked out, try to understand everything. Then you'll be ready for your first practice test. And take this one. This cover page is identical pretty much. You don't know what form you have. There's 9 different forms. You have no idea what form you have. I keep them very similar. And read all the directions. Did I provide a Scantron form even? Maybe I didn't. I usually do, but maybe I didn't. Sorry. Oh, well. Do that, and then you do the key. You look at the key, etc. Now, here's an honors agreement. Read this for the bonus points. I'm going to be sending you an email about that. How many people have already know where the grade calculator is and have looked at it? You don't? Okay. So you go to the website. All right. Let's get rid of this, and we'll just go to our website, and up here. Okay, first off, this is where you go. You just go on a Follinger. And this is the final exam. Where am I? I just Googled Stat 100. And I clicked on, what did I click on here? Exams. Here is all about your exams. Where you go, exam policies, conflict policy, practice exams are all here. Everything's on this page. It's on other pages too. Here, if you want help, we have help. Up until, we have help all through the exam period, and here's where you can get help. This is just on our website. Just click where you think you should click. What else? Let's look at, what else did I want to show you? Oh, so here is where you can estimate your grade. You can do these calculations, but once you have all your scores on Compass, everything, and read all about the bonus stuff, where do you read about the bonus stuff? I'm sorry, you have to go read about the bonus stuff here, and it tells you how everything's, and if you're missing a lecture, what you have to do. I'm going to, you should explore this site. But if you want to just jump to it and estimate what you need on the final to achieve whatever grade you're aiming for, you just go right here and download an Excel file. And so here's some students who already did it. I'm not sure if it works if you do a new one. I always cover up one that's done. All right, so let's say, I don't know, that you got like a 70, I don't know, 5 on your exam average. But you've been doing great on the homework, and you've been doing great on the bonus points, and you're trying to see, I don't know if you can you get a B? Let's see. What? You only need a 60 to get a B? Wait a minute, that's a B minus. Can you get a straight, does that make sense? A straight B, 83. Can you get a straight B? Yes, you'd need to get a 70. Can you get an 8? This is how you could do it. Can you get, what's the highest you could get? If these were your scores, can you get an 87? That would be a B plus. Then you'd have to get an A. Now, let's say you're at the point where you're at an 88. What do you need to get a straight A? Your target grade here would be a 93. What would you need? And you'd need a 93. Now, people are going to say, why? Well, you only have a B plus here. So you need to get an A. If you want to get a straight A on the final, for your final grade, you're going to have to do this. This helps people who really need the points more. But still, it helps you quite a lot, because without the bonus, you would need a lot more. And if you just wanted to get an A minus, then what do you need? Only a C plus here. And if you just wanted to get a B plus, then you'd only need to get a 63 on the final. So you can just fool around with that, and it works different for every person. The idea is, why I do this is not so you can game the system and say, okay, I don't want to work a second more than I have to, and I'm only going to aim for a 63.9 because all I care about getting is a B plus. You will lose, probably, because you'll lose, and I have no sympathy for those people. They do it all the time. They say, well, all I needed. I said, you're trying to get a B plus and you got a D on the final? No way. Whereas if you go the other way and work really hard and do really, really well in the final, I'm much more likely to give you a little wiggle room up there, because it means you're really trying at the end, you've integrated all your material. But I have no sympathy for people who do this type of thing. all right. Now is it time to say goodbye? Or not? I was gonna have us do another clicker question or a what was I was gonna have us do something fun. Now I remember. I forget what it was. Oh, I was gonna show you this. Just have I like this YouTube video, but now I don't know where it went to. So what? Yeah, but it might play a wrong video. Right here? Press the circle? Okay, I like this. For all of you who take
look at this Instagram. It's been inside of him. Started out as a lemon tart. Then my phone went and made it